Hi, everyone.
Hey.
Hi, Brad. Hi, Deborah.
Hello.
Hey there.
Hi, Brian. Hey. How's everyone? Any realizations lately?
My realization is how much I don't know, but at least I'm starting to know what I don't know.
Good. How did you have this realization?
Well, I was looking at the reading, specifically the one that goes into like promises in depth.
Mm-hmm.
And it goes through it, in sort of baby steps in this very nice way. And the baby steps were too much. Like I couldn't quite read that initial little function. I didn't understand what was, really what the pieces of that function were referring to. So I've gone back to Mozilla, some tutorials there, and
Okay. Yeah. Right. That article is really nice. It's a really good exercise, but it is difficult. If you haven't used promises before, just as a user, if you haven't used them, then the article is going to be hard. So it's something to come back to. Has anyone been doing katas along with the course?
No, I haven't.
You haven't? Yeah.
No. Yeah, I'm kind of in the same boat as Deborah. This promises article is breaking my brain right now.
All right, good. I mean, that's good. That's a stretch goal, I think. But you definitely want to start with just using them and get comfortable using them.
Yeah, I mean, I think I get the basics of it in terms of what they offer and kind of the structure. It's just trying to read this code is just, I'm having a really hard time with it.
Yeah, sure. Yeah, it's hard. Yeah, it's very abstract as well. You're not dealing with users and people and names. It's promises and values and just really abstract concepts.
Yeah.
So you can get lost pretty easily. Yeah.
And what was the verb? It was something like venable. If something is venable. Yeah. My
wordsmith brain is just, going nuts.
Yeah, there used to be a lot of promise libraries and different ways to do things. And an object that has a then function, that's like the minimum that you need to have some kind of promise. So people like to say venables instead of promise sometimes. It gets confusing.
The romantic in me likes the word promises.
Yeah. Venable is terrible. Yeah. Good. Yeah. Well, so I hope it's not. I hope you don't get disappointed when you see material like this. I hope it's not too hard, that you lose hope. Hopefully, you can just ignore it for now, come back to it, and just keep going. Yeah. Good. Hi, Tony.
Can you guys hear me?
Yep. Okay.
Okay.
Nice. Good. Any questions on the homework or the readings?
Nope.
Yeah. Okay, let's just wait a minute or two, and then we'll get started.
I can share in the chat a link to some tutorials that I'm finding helpful as a total JavaScript novice, and actually any sort of object-oriented programming novice. I'm new to that, so I'm finding these Mozilla ones really helpful.
That'd be great. Thanks.
Yeah.
Yeah. These tutorials are discussing what kind of topics? Is it the event loop or something like this?
It's everything. It's like it literally says, what is JavaScript really? It's JavaScript basics from the Mozilla Developer Network.
Yeah, I've been using that a lot too, Deborah. It's been great.
Yeah.
Good. Yeah, that's very good. And if you want to share the links in the Slack channel, that's probably best, because we're going to lose that chat at the end of the session, the Zoom chat.
Okay, I'll put it in this Slack channel. Should I pin it or what? Or just put it in?
Yeah, that's a good start.
Okay.
Okay, good. So let's get started. So today's topic is object-oriented programming and how that works in JavaScript. In practice, we're going to talk about the this pointer. We're going to talk about prototypes, delegation, and the constructor calls, and that kind of thing. So it's a topic that can be confusing. If you come from a different language, you might be even more confusing. The way it's done in JavaScript is actually not that complicated. There are various ways to do things, and there's a lot of confusion out there on the internet. So we're going to try and take it one step at a time, and we're going to try and show you a simple way to think about things. And let's see if we can do that. Let me share my screen. Okay. Oops. Okay, good. So, is everyone here? Good. Good. So let's just have a quick look at the last lesson's code pen. You might remember this code. This is our to-do list, right? So this is the working version. Get bread, juice. I can remove things, and this code relies on the create to-do function, which adds a to-do to the list, and it creates an object here, which is a to-do, and it has an add to list function on it. Okay, and if you remember here, we select the element, and then we select the remove button, and on click we call this.remove, and we expect that to call this remove function here. So this is the fixed version. The last bug that we fixed was when the code was looking like this, and it said this.remove. And so this failed because the value of this, when remove was called, was different. It wasn't the to-do object anymore. It was probably the global object, which was not useful. And so when we were running this code here, this.element, this was the global object. It wasn't the to-do, and that would fail. So we fixed this by adding bind this, which will take the value of this and carry it over into the remove function here. So let's keep this in mind, and we'll come back to that, and we'll talk more about how this works. Good. So let's start with why this is useful at all. Yeah? So here we have an example of a create new user function. And what it does is it creates a really simple object. It's an object literal, and it has 4 properties. Right? So I'm using an ID here, first name, last name, and a creation date. It's pretty standard. But what's important here is that the create new user function encapsulates everything that you need to do to create a user. So everywhere you want to create a user in your code base, you want to call this function, and it will always create a user in the same way, and it will take care of the ID and the creation date and that kind of thing. So that works well. Let's actually try and use this code. So I'm going to paste that here. I'm going to create a user. So I'm going to do let Alice is equal to create new user, Alice Johnson. Okay, so that's my user. Alice is my user. If I look at Alice, I get this object with my 4 properties. Right. So this seems to work well. Alice has ID 1, and the next user would have ID 2. That works well. Okay. So far we have only properties. We don't have functions. We don't have behavior. So let's add that. Here in the second example, we have the get full name function here. So this is the first piece of behavior that we're adding onto the user object. Good. So here in the get full name function, we want to return the full name, which is the first name and last name together in a string. Okay. And so we're going to want to reference ourselves and access our first name and last name. So here we have one example of how not to do it. Okay, so I'm doing return first name, last name. But first name here is really referencing the parameter first name, and last name is referencing the parameter last name. Okay, so if I use code like this, it might look like it's working, but if you actually try it, if you do let user create user Alice McIntyre, if you log the full name, it's going to work. But if you change the last name of the user, if you do something like user.lastname and then change it to McIntyre, here I'm fixing the last name. Okay. At that point, if I call get full name, I'm still going to get the old values. I'm going to get whatever the parameter values were. Okay. So get full name isn't really referencing the new values on the object. Right. That's most likely a problem. So we're going to have to reference ourselves. Okay,
Can you talk about the $ and what that is, what its function is there in front of first name and last name? Yeah, and
sure.
when we use it.
Yeah, so here, this is just a normal string literal. I'm using backticks here to create the string. And then within a string that is within backticks, you can use dollar braces to kind of evaluate a variable. So if I do dollar braces first name, I'm just going to put the value of first name into that string. That's all that's happening here. So yeah, so it's very similar to doing first name plus last name.
Thanks.
So yeah, it's nicer to do it that way. Otherwise, you start plussing a lot of strings together, and it's hard to read. Whereas this is kind of nice. So yeah, so that's all that's happening here. So yeah, so we have this bug. We have this bug where it's not referencing the properties from the object itself. So that's what this is useful for. So we want to get away from these parameter values, and we want to start referencing the object, this object here that we are returning. So we can use this. So here we have the bug-free version of the code. It says return this dot first name and this dot last name. Okay, and if we use this code and run the test above here, this would actually work with this version of the code. So as you change properties on the object, the get full name function will keep referencing these new values and will actually give you the result that you expect.
And what would you say to someone if they said, what does this, in this situation, what does the this refer to? Is it the function? Is it the...
It's not the function. It's the context. It's the current object.
The current object.
So that's a little abstract, but it's with practice it becomes natural to think of it as just the context or the current object. In this case, you can see we're returning an object. Right? We're doing return curly braces, and so this element in my code, that's the object. Okay, and so within that object, if I use this, I would expect this to refer to this object. But yeah, it's almost never the function, right? It has to be an object, and yeah, and you can play with it as well. So depending on the case, depending on how it's called, this can refer to different things. So it's never really clear what this refers to, but usually you can tell. It's just clear from the intent. Right? So here we have a get full name function on a specific object, and when we do this dot first name, it looks like we want to refer to this first name here. That's kind of if you trust the developer, if you look at the intent of that code, it's pretty clear. Yeah, good. But it can be very confusing. So here's an example that we've seen before. Okay, we have a variable called name that points to Bob, and then we have an object called Alice here. This is the object. It has a name and a greet function. Okay, and here I'm using setTimeout to call alice.greet in a second from now. So what do you think will be printed to the console when I run this code? Here's the code again.
First it'll print Bob, and then after a second it'll print Alice.
I think it will just say hello, Alice, after a little bit.
Right. Yeah. So hello, Alice is the intent of the code. That's what we want to do. But yeah, as you would expect, it's not going to work. Let's see. Yeah. Sorry. Let me reset this up. Let me run this now. 1 second. Hello, Bob. Okay. So it doesn't say hello, Alice, as we would have liked. It says hello, Bob. And that's because the value of this isn't what you expect. Okay. So the actual object that this refers to is a bit hard to pin down. Depending on how the function is called, it's going to point to different things. Okay. So if I do alice.greet and call it just like that, it's going to work. Right? It's going to say hello, Alice. Okay. And if I use the setTimeout version, it's going to say hello, Bob, because when I use the setTimeout version like this, the function is going to be called later by the browser in such a way that this won't be pointing to Alice anymore. It'll actually be pointing to the global object, to window. Okay, and window has this name variable on it. So it's actually going to say this, which is window.name, and it's going to find Bob. Okay, so that's an example of how this can be tricky. And we're going to have a look at how to figure out what this points to and how to guard yourself against these bugs.
Can you, so I would have thought that the setTimeout, I would have thought if you put Alice outside of that function, the var Alice function, it would have referred to Bob anyway. But you're saying that it would refer to Alice unless the setTimeout was used?
Yeah, so it's not the setTimeout's fault. It's just the way I'm using it here. So this is just a basic example of how this can be tricky. And I'm not sure what you meant by what if Alice was outside the function?
You had called alice.greet.
Mm-hmm.
Well, never mind. You can just continue. What you said helped.
I got a quick question. Why is it even running it at all with before the second? Like you're saying call alice.greet in a second. So why is it going into the greet function before the second?
Well, I mean, it does wait a second and then it calls the function. Right, that's what's happening.
So why is Bob? I guess I still don't understand why Bob is the one. Because if it's going into the Alice object and calling greet,
yeah.
I mean, it's still intuitive to think that Alice is this, as opposed to like where it's getting Bob from.
Definitely. Yeah, so you would expect Alice to be this. It just doesn't work that way because this is dynamic. So you can't look at code and know what the value of this is going to be.
Should you always? I'm sorry.
Yeah, you have to look at how this code is exercised, how it's actually called. So if you're not careful, you run into these situations.
Should you always use bind in that case? Or I think it's bind.
Yeah, you could. That's one fix. So you come here, and then you just say Alice, you just say set timeout Alice.greet, and then you say, I really want Alice as the value of this in a second, and then that's going to work. Hello, Alice. Yeah. So that's one good fix. But yeah, let's just agree that this is tricky, and then we'll talk more about how to fix this. Good. So what we want to know is what does this point to, right? So we can write some code, and we can try and make our intent clear. We've seen a few examples of how you would want to use this, and that's all good. The problem is in how you would call this code. Okay, so let's try and figure out rules as to figure out what this is pointing to. Right? So here's the simplest case. You have the Alice object, name and greet, and then you call alice.greet, and it says hello Alice. Right? So this works well. We're not using set timeout. We're not dissociating the function from the object. And then this is the normal case. 90% of the time, that's how you're going to use this object, and it works well. Okay. Now, the way you know this points to Alice is by looking at the left-hand side of the period. Okay, it's that straightforward. So alice.greet here, the function is being called here. Okay, the parentheses are there, so the function is being called on that line. Okay, and on the left-hand side of the period, you have the Alice object, and so this will point to Alice. Okay, that's the normal case. That's the literal way of looking at this, and it works well. Okay, now let's look at some situations where this is not going to be the case. So here, I have the same Alice object. Okay, but I'm dissociating the function from the object. I'm saying alice.greet. I'm going to take that function and store it in a new variable called fn. Okay, and then I'm calling it. I'm calling fn. Okay, and so when fn is called, there is nothing on the left-hand side of the period, and that's a clue for you to know that this will no longer be pointing to Alice. It'll actually point to the global object. Okay, because there is nothing on the left-hand side of the period.
Could you have written that let statement with brackets, parentheses after greet? Like alice.greet, open, close paren?
I could have, but as soon as I use parentheses, that's going to call the function.
Got it.
So in this case, I didn't want to call the function. I just wanted to store it in a new variable. Yeah. So this is what's happening here. I'm dissociating the object from the function and calling it afterwards with nothing on the left-hand side of the period, and that will confuse the this pointer. Okay, here's the other example that we had before. Here it might look like the greet function is still associated with Alice, but it's not. All right, so there are no parentheses here. I'm just passing in a function to the browser to call later. I'm not calling it. This is not the call site of the function. So you can't say that Alice is on the left-hand side, therefore this points to Alice. That doesn't work. This only works when you have parentheses. Right?
Hey, Matt, can you go up again that function? Just you were there before.
Which one? This one here?
The top one where you stored the variable into the variable, the function.
The fn one.
Equal to alice.greet. Yeah.
Here. Yeah.
Yeah. So what would happen if you now say set timeout fn?
So yeah, that's exactly the same as this. So whether you do set timeout alice.greet or set timeout fn, it'll be the same thing.
Okay.
Yeah. So both of these fail. Okay. So yeah, good question. So if you did set timeout fn 1000, you'd have the same outcome. Yeah. So in order to know what the value of this is, you have to look at the call site. You have to look at the line of code where the function is called, and this is not it. Right? This is not the line where the function is called. The function's actually called by the browser later, and the browser won't be doing alice.function. It'll just be calling that function, just like that, without anything on the left-hand side. Good. So how do you fix this, right? So sometimes you do want to use set timeout, And as I said before, it's not set timeout's fault. Set timeout is just an example. Every time you use a callback, you're going to have that problem. So set timeout is just a simple way of using the callback. So let's just fix this. All right. So we want to make sure that even though we're using a callback, we want to make sure that this is pointing to Alice. Okay. So here we have the same object again. Let's see how we can fix this. So one way is using bind, which we've already talked about. So this is about explicitly specifying the value of this whenever that function is called. Okay. So we're doing alice.greet, and we're not calling it, we're calling bind on that function, and we're specifying the value of this here explicitly. So at that point, we can do set timeout fn, and the value of this will be whatever we specified here. That's a good fix. Another fix is to use a wrapper function. Okay, so this one, this fix is less explicit, but it works well, and you're going to see that a lot. I'm creating a callback, the fn function, okay, and then within that function, I'm calling alice.greet. So this is a way of taking control over the call site. Right? So this is where alice.greet is called, but we don't want to call it just yet. We just wrap that into a function, and then we make that function the callback. So it's a level of indirection. Good. Good. So something you might have seen as well. So another way to fix this would be to use some kind of trick, like var self equals this. You might have seen this before. I don't think it's a good idea. I think it's noisy, and you might as well be explicit about it, and you might as well understand how this works, and not resort to these hacks. Good. Any questions on this? Yeah. No. Okay. Good. So let's keep going. You can have a look at these at this terminology note later. Let's talk about call and apply. All right, so we've talked about this. We've talked about the call site and how to take control over the value of this. And so call and apply will insert themselves into that context.
Sorry, Matt, can I ask one quick question? Sorry to interrupt.
Sure. Yeah.
Back up top, when you let fn, you like, I'm not sure what the terminology called, but equals parentheses equals this function with alice.greet in parentheses afterward.
Yeah.
I just, when messing around, kind of following along in CodePen, and if you just get like, because I understood something from something else I was looking at, but if you get rid of the middle parentheses and equal sign and get rid of the arrow and just let the fn equal alice.greet with parentheses, it still calls hello Alice.
It does, but it calls it right away.
Oh, gotcha. Okay, so you're storing it, kind of. I think I get that.
That's right. Yeah.
All right.
I'm creating a function that will call the right function later.
Gotcha.
That's the point. Because if you just want to call it now, you can just do alice.greet.
Yeah, that makes sense.
And that's going to work.
Gotcha.
Good. Okay. So yeah, let's talk about call and apply. So call and apply are basically working in the same way. So we're going to talk about them together. And it's another way for you to take control over the value of this. Okay. So let's see how that works. One thing to keep in mind is that if you're just getting started and you find this confusing, as you get better and as you talk to JavaScript programmers, you might find that those programmers actually like the way this works. It's flexible and it gives you power. So call and apply are ways for you to like harvest the power of this. So it's not just a source of confusion; it's also a source of pride for the JavaScript developers. So let's see how call and apply work. So here's one example where you could use them to fix a bit of duplication. Okay, so we have the Alice object and the Bob object, and they both do the same thing. They have a name property, they have a greet function, and they say hello with their name. The obvious problem is that we have duplication. Right? So these two objects really are the same code. Okay, and if we had a third one, we potentially would have the same code again. So we'd like to find a way to have just one snippet of code that we can use for both Alice and Bob. Okay, so here's one way to do it. Right, so you can see the snippet is shorter, which is nice. And we have a person object here. It has one greet function that is going to be shared between Alice and Bob. Okay, and here we have Alice and Bob again. So there are two objects. Each one has a different name. And now we want to be able to call greet on each one. Right, so we have one function, but we want to be able to call it on two different objects. Right, so you can use call for this. So you can do person.greet.call, and then you say Alice as the first parameter, and that's going to call the function for you with Alice as the value of this. Okay. And you can do the same with Bob. That's going to work as well. Okay. Something else you could do that isn't here is person.greet.bind Bob, and then put parentheses there just to call it. So let me paste this here. So let me paste this example here. Yeah, let me reset the state. Okay, so here's this hello Alice, hello Bob. Okay, so we have the same function called on two different objects, which is nice. We've removed the duplication. Here's another way you could do it. If you want to use bind, person.greet, bind Bob. So here I have a function that is bound to Bob, and I just need to call it. So I'm just going to add parentheses here. So it might look a little strange because you have parentheses followed by parentheses. But this is valid, and this is going to say hello Bob, and you could say the same with Alice.
That semicolon at the end is optional.
It is, yes. I'm actually in the process of removing the semicolons, but you'll find a few still.
Hey, Matt, if you go to the top of the function, you could also have done something like you could pass name as a parameter to the greet function, and then you can say let Alice is equal to new person and pass the name, right? You can do that also.
Yes. So we haven't used constructor calls yet,
Okay.
but you could use constructor calls as well. Yep.
Should we get in the habit of using semicolons at the end or not? What's the argument either way?
Yeah, you can spend a lot of time looking at both sides. My current opinion is that semicolons should be removed.
Any reason why, or?
They're just noisy. So instead of worrying about putting them in, you just don't worry about it. Yeah, there's I think there's three situations where you would need one, and that's if the next line starts with a backtick or a bracket or a parenthesis. So in those cases, you might want to add one, or you might want to rewrite the code so that it never starts with a bracket or a backtick, that kind of thing. Yeah. You can also, like if you want to write a line of code that starts with a bracket, you can also do semicolon and then your bracket, and that's going to be fine. So you have these three situations, and then otherwise the semicolons are not useful. Yeah. Good. So let's come back here. Okay. So yeah, let's look at constructor calls now. So so far we've created objects using the literal syntax. Right? So we were here, and every time we wanted an object, we did something like let obj is equal to curly braces. Okay, and that creates an empty object. And if you want something in that object, you can just put it in there. Name Bob. Yeah, sorry. Let object2 name Bob, and that's our object. And then we can do obj2.name, and then we get Bob. And so that's how we've been creating objects. It's nice, it's simple. That's actually my preferred way of creating objects. But you will see the new keyword, and you will see constructor calls. And so let's talk about how that works. Yeah, so constructor functions will often look like this, but they're not special. They're just normal functions. Okay. So conventionally, they will often be capitalized. So here you'll see const dog. So capital D dog is equal to function, and that by convention this makes the dog function a constructor. Okay, and the way you use a constructor is by calling it with new. So if you do new dog, you're going to be creating a new object. Okay, by calling this function, and that's it. So it's an alternative to curly braces. Okay, arguably it's more complicated, but you will see this. Okay. And within that function, within the constructor call, the value of this will always be that new object that you're currently creating. Okay. So if you see something like this, here I'm doing new dog. There's no period. There's nothing on the left-hand side of the period. Well, that's okay. New is a special case. Okay. And then within that function, this is the new dog, and I'm specifying the name of that object as Fido. And if I console log that puppy.name, I get Fido. Okay. So this in that function refers to the new object, and it's automatically returned at the end of the constructor call. Okay. So this is a special case, and all of these special things are triggered by the use of new.
Wouldn't you have to use this particular case if you were to have like somebody signing up for a website and the object doesn't exist or the new person doesn't exist yet? You have to call new once they click register or something like that? Or can you still use the old way?
Yeah, you can still use the old one. If you look at create new user, which we had before here, all right, so this is an example of creating a user without new.
Okay.
All right, so
then you just call create new user.new or like let something.
You just call it. You create new user, and it's
Okay.
going to return to you the object.
Okay. That's right.
So I prefer this style without new because there's less magic. There's fewer special cases, and it's more explicit. You return this object, and that's the user. Good. So let's come back here. Good. So yeah. So this is a special case for this. If you're inside a constructor call that's been called with new, then this is the new object. That's the way it is. Good. And then another case of the value of this changing is within arrow functions. All right. So if you use this new function syntax here, then you are implicitly binding the value of this to what it is outside of that function. Okay. So in this case here, I'm calling new Alice at the end here. So that's going to be a constructor call. Within the Alice function, I would expect this to point to the new object. Okay. So that's true here. We're setting the age to 0. And then here we're doing set interval. So we want to increase the age every second. Okay. And because I'm using this syntax here within that function, the value of this will be the same as the value of this outside of it. Okay. If I were using a normal function syntax, that would not be the case. The value of this would be gone. It wouldn't be the same as here. Okay. So that's just something to keep in mind. Whenever you're using the arrow syntax, you're also implicitly binding this.
What in that set interval is pointing back to the Alice function? Oh, I'm sorry. Never mind. Stupid question. It's inside the braces. Got it.
Yeah, that's right. It's within the Alice function. Yeah. And we're just trying to increment the age every second using this. Good. So yeah. So if you're looking at a bit of code and you're wondering what this is pointing to, you want to follow these rules. So this is from the You Don't Know JS book, and you can follow these rules in order. All right. So if the code is called with new, if you're in a constructor call, then you know that this points to the new object. If you're being called with call or apply or bind, then it's explicit. You can have a look at the first parameter of either of these 3 functions, and then you'll know what this points to. If none of these are the case, then you can check if there is something on the left-hand side of the period. If so, that's this. Okay. And if none of these cases apply, then you'll know that this points to window or the global object. And if you're in strict mode, which I would encourage, then this will be undefined. So you can't use it basically at that point. So these are the 4 cases that you want to go through, and you want to go through in order: 1, 2, 3, 4. Good. So
how do you implement strict mode when you're developing?
You want to have in whatever file you're in, you want to have a line that says use strict in a string. So if you're in a whatever, yeah, sorry, if you're in here, if you do use strict like this, you'll be in strict mode, I think. Yeah, and that's going to enable strict mode, and you can also do it inside a function as well. So basically, it's a good idea to, in your code base, to have as the first line of each one of your files to have use strict, and that's going to instruct the engine that you're in strict mode, and that's going to turn on a lot of things. It's going to make JavaScript a little stricter, a little less flexible, and it's probably going to show you more errors. Yeah, it's probably going to show you more errors, more things that look like bugs are going to be caught by the strict mode.
Is that the advantage of using it, or is there another advantage?
Yeah, that's it. So it just makes the JavaScript more predictable. And yeah, so in cases like this where this points to the global object, that's really confusing. It's probably not what you meant. Right? Usually you want this to actually point to an object, not window. So in strict mode, this will just be undefined, which is nice. So if you call anything on this, it'll throw an error. So that's kind of what you want. It'll make your bugs easier to see because it will explode instead of just ignoring it. Yeah. So if you look at the Alice Bob example, here, this example here, in strict mode, that would fail. It wouldn't say hello Bob. It would actually say I don't know. I can't find name on undefined. So in strict mode, you get an error, which is good. In non-strict mode, you get hello Bob, which is terrible. It looks like it's working, but it's not. Does that make sense?
Yeah.
Yeah. Good.
And Matt, most of the developers in all the development environments, they use strict mode. Is that correct?
I hope so. Yeah, it's definitely a good idea. There's no good reason not to use it. Yeah. Good. So let's try and apply these 4 rules. Okay. So I'm going to give you a few examples, a few code snippets, and you tell me what this points to.
I have a really quick question on the strict mode. If you're developing a site that you didn't start with from scratch, you're kind of jumping in, maybe it's on a CMS or somebody else built it. Is there a quick way to test if the site is in strict mode?
Right, so strict mode is not per site, it's per file or per function.
Per page, oh, okay, per file or per function.
Yeah.
Okay.
So it's not really web related. It's not per page or per URL. It's not like this. It's per JavaScript file.
Okay.
So
is there a way to test if the JavaScript you're currently working with is already in strict mode, or if you don't have access to edit those files? Let's say you're working in a CMS, you have access to certain files but not other files. Is there a way in the console or somewhere to test if you're working in strict mode on the current file you're in, the current page you're troubleshooting?
There must be. I mean, one way would be to look at the behavior that we just looked at and catch the error. And if there's an error, you know you're in strict mode.
Okay.
But there might be a better way. That's a good question. I'll get back to you on that.
Okay, thank you.
Good. Okay. So yeah, I would just recommend using strict mode all the time. It'll make your life easier. Good. So let's have a look at. So let's keep the 4 rules here. Okay. And then let's have a look at the first example here. So yeah, just have a look at this code snippet here. We have an Alice object with a name. We have a greet function, returns this.name. And then we have alice.greet is equal to greet. Okay, so we are assigning the greet function onto the Alice object, and then we're calling it. So what do you think this points to here? This line here.
Alice.
Yeah, so this example works well. Okay, so if you go through the rules in order, is it called with new? It's not. So we move on to number 2. Is it called with call, apply, or bind? It's not. So we move on to number 3. Call with a context object? Yes. So when the greet function is called, it's called here. On the left-hand side of the period, we have the Alice object. Therefore, this will point to Alice. Okay. Let's just confirm that. So we're expecting Alice's name here. Yeah, so this works well. Okay, good. Let's try this code snippet here. Whoa. Okay, so here, okay, we have a counter object with a value of 0 and an increment function. Okay, and the intent here is to take that value and increment it. Okay, and then here on the last line, I'm using set interval to take that increment function and call it every second. So what do you think this will be pointing to here?
The value inside counter. Oh, sorry, never mind.
Right.
Never mind.
Yeah. So yeah, this value will be the value, and this will point to counter. Okay. So if you go through the rules in order, is it called with new? It's not. So increment is called here, or actually it's called by the browser every second, but it's not called with new. Is it called with call, apply, or bind? Yes, it is. And so you know that the value of this will be the first parameter of bind here. Okay. So that's rule number 2. Good. Let's try this one here. So we have a dog object with a cry property and a bark function. Okay, and in here we do console log this.cry. So we're expecting this to print woof. And here we are doing document body add event listener, click dog.bark. All right, so we want to bark every time the user clicks. What do you think this will be pointing to here?
Not cry.
That's right. Yeah, it won't be dog. Yeah, good. So if you go through the rules in order, is it called with new? No, it's not. There's no new here. Is it called with call, apply, or bind? No, it's not. So we go to rule number 3, which is the function called with a context object on the left-hand side of the period. It might look like it is, but it's not. There are no parentheses here, so that doesn't count. The function is actually called later by the browser. And so we get to case number 4. There's nothing on the left-hand side of the period, and so this will point to the global object or will be undefined in strict mode. Okay, so this is almost certainly a bug. Yeah. Good. Let's try number 4 here. We have a dog object. It looks like a constructor because there's a capital letter here. Although this doesn't make any difference to JavaScript, but it's just for us as humans. This function looks like a constructor. It's called with new. Okay, and it does something similar. So it has a name, Fido. It has a bark function, and it's trying to bark into the console to bark from Fido. Okay, and here we're doing the same thing. When the user clicks, we create the dog and we pass in the bark function. Okay, so this is a similar case as before, but a little bit more complicated. And what do you think this will be pointing to here?
The dog object.
Dog object, yeah. Yeah, that seems right. So if we go through the rules, rule number 1 is the function called with new, and it sort of is, right? So the function is defined here within a constructor call. So the value of this will be the new object, the new dog, okay? And within that function, we are using the arrow syntax, right? So we're expecting the value of this to be the same as it is outside. So we're expecting this to be the new object. Let's see if we can make that work. So I'm going to click here. There you go. So that works well. Every time I click, I get a bark from Fido. Good. So there's a lot of things happening here. There's the use of new, which will bind this to the new object. So we can do this.bark, and that'll be the new object. And there's the use of arrow syntax, which will carry over that binding into the new code, the new function. Okay. Good. Let's see.
Matt, I have a question on the last one on 4. If there weren't the forward arrow, how would that affect?
Yeah. So without the arrow syntax, you would end up in a case very similar to this one here.
Right.
So this would not point to what it pointed to outside. It would point to the global object or undefined in strict mode.
Got it.
If you just put parentheses behind bark in example 3, it'll work. Or is that correct?
Behind parentheses, right? So you can't put parentheses there because that's going to actually bark, and we only want to bark when you click.
Oh, that's not going to save the bark to the click even though you put them there, because of the.
Right. No. So if you put parentheses there, you're calling the function, and so you'd be registering the return value of that function as your event listener.
Huh. Okay.
Right. So yeah, you have to be careful about these parentheses. One way to simplify this reasoning about this is to think about what would happen if you had a variable that would contain that value. So if you have this code here, okay. If you let me get rid of this. So here I'm trying to add the event listener on click. If I do new dog.bark here with parentheses, I'm calling the function, okay? And then if you want to know like what would happen if I did this, you can just take this code and replace it with a variable fn, okay? And here I'm going to do var fn is equal to all that stuff, okay? So here it's really clear that you're trying to pass in a function here, and you're expecting this bit of code here to actually create that function, which doesn't really make sense because you're creating a dog and then calling bark. So this would make sense if bark returned a function, but that's not really the case. Bark is just logging something to the console. So assigning its return value to a function and then adding the event listener doesn't make sense. So that I find that clear using that way of doing things. So you just store your new function inside a variable and then use that variable in your add event listener. That makes the use of parentheses or not clear, more explicit. Good. So I think I'm going to skip the rest of these examples, but you feel free to go through them and test them out yourself, because I want to get into the prototype chain. Okay. So yeah. So we've talked about objects and how to call functions on different objects. We've talked about this, which allows an object to reference itself. And once you can reference yourself, you can use your own properties, or you can call other functions from the context object, and that's very useful. But something else that we might want to do is share behavior or properties across different objects. So you might have a user object, or you might have a subscriber object or a follower object, okay? And all these three objects might want to have a get full name function, okay? So you have one bit of behavior, you have one function that you want to share across three different objects, okay? So that will happen quite a bit, and that's what the prototype chain is for. It allows you to share behavior like this. Okay, let's have a look at this in detail here. We'll come back to this. Good. So yeah, so try and keep that in mind. How would you share behavior between objects? And we'll talk about the delegation and the prototype chain. Okay, so let's try and make this simple. There's a lot of confusion around this. So yeah, let me see if this makes sense. So when you look up a property on an object, it's just going to look at that object and it's going to look for that property. Okay, so this is the simplest case. All the cases we've seen so far, they were like this. So we have a dog object. Okay, it has a name. So if you do console log dog.name, you find Fido. Okay, so JavaScript's going to look at the dog object. It's going to look at whether or not it has a name property. And if it does, it's going to take it and give it to you, and you get to log Fido to the console. Okay, so this works well. That's the kind of thing that we've been doing so far. Okay, now what if you use the prototype chain to actually share behavior? Okay, so here we have a dog object with a name property, and I'm going to create another object called Fido. Okay, and I'm going to link it with the dog object. Okay, so here I'm using object.create, which we haven't used before. But basically what I'm doing here is I'm linking Fido with dog, or dog to Fido. Okay, so these two objects are now linked. And if I look for something on Fido and I don't find it, JavaScript is actually going to go and look on dog to see if it's there. Okay, that's what object.create does. It'll link the two objects together. Okay. So if I do Fido.name, even though I haven't defined name on Fido, it's going to find it on dog because the two objects are linked. Okay, so it's a chain. It starts to look for properties on Fido. If it doesn't find it, it goes onto dog, and it's finding it there. Okay, good. So
what do you call object.create? It's not a function. Is it an API? It is a function.
It's a function. Yeah, it's a global function. Well, it's not global. It's on object. So it's a standard API that's given to you by the browser.
Is it similar to like if you say let Fido equal to new dog?
It is similar. Yes. Okay. That's good. It is similar, but this new way of doing things has edge cases that are confusing. Object.create is much clearer as to what it does. I think we have examples of using new coming up after this. Good. But yeah, I want to focus on object.create because it's simpler and it's more modern. I would encourage you to use object.create as opposed to new. Good. So here we do the same thing, but the chain is going to be a little longer. So I have this dog object, and then I create the Fido object. I link it to dog, and then I have the puppy, which I link to Fido. Okay, so we have 3 elements in that chain. And if I look for puppy.name, it's not going to find name on puppy. It's not going to find name on Fido, but it's going to find it on dog. Right? So if I log puppy.name, it's going to say Fido in the console. Right? So that works well. Good. And then the question is, what happens if it can't find it? Right? So here we have the same example. We have dog, Fido, and puppy, but I'm looking for puppy.age, which doesn't exist on dog. So it's going to look for age on puppy. It's not going to find it. It's going to go to Fido. It's not going to find it. It's going to go to dog. It's not going to find it. And then at that point, it's going to return undefined. Right? So JavaScript searched the whole chain and didn't find anything. So you get undefined. Okay. Good. So this is a behavior that you can use. Right? So if you want to share a property across objects, you can just link them like this with object.create, and then multiple objects can share the same name or the same whatever. It could be a function like get full name. Whatever you want to share, you can share it like this with a prototype chain. Good. Now, things get more interesting when you set a property. Okay. So here we have our dog object. We have Clifford, which we're linking to dog, and then we're setting a name on Clifford. Okay. We're setting a name on Clifford. So here, there's a question as to what's going to happen. Will the name be set on Clifford, or will it be set on dog? So on which at which step in the chain are you actually setting the name? Okay, and the answer is it's almost always going to be on Clifford, on the lowest rung of the chain. So if you do Clifford name is equal to Clifford, you're setting the name on Clifford, you're not setting it on dog. Right? So dog's name remains Fido, and Clifford's name is going to be Clifford. So both can coexist like this. And if you think about it, this is the right way. This is the way this should happen. Because if you're sharing properties among different objects, you don't necessarily want the properties to be overridden by other links in the chain. So it makes sense for these properties to kind of go down if you set them. So if you had another object, for instance, that is linked to dog, you wouldn't want that object's name to become Clifford. So this behavior makes a lot of sense. Whenever you set a property, it's going to set it at the level where you're setting it. So if you set the property on Clifford, the property is set on Clifford. Good. Now, there's a lot of edge cases to this behavior. If you're using setters, the new setters syntax, or ES6 proxies, or the writable flag, those aren't really things we're going to talk about. But if you use any of these things, then the scenario above won't work. All right, good. But this is definitely the normal case. Good. So object.prototype. Okay. Now this is the crux of the issue. So all the objects that you can create will have a chain, a prototype chain, okay? And that chain will end at object.prototype, okay? So all the functions that are defined on object.prototype will be available on all of the objects that you create, right? This makes sense. So if you do new object like this, obj is equal to new object, you're creating an object, and this is, yeah, so this is an example of using new. This is very similar to doing object.create, and it will create a new object, and then by default, the objects will be linked to object.prototype. Okay, so object.prototype is the end of all the prototype chains, if you will. Okay, and so another way of saying this is that whatever property or function is available, defined on object.prototype, will be available on all the objects in your code. Okay, so if you've wondered where the toString method comes from, it comes from there. So if you look at all the functions defined on object prototype, you get this list, and toString is there. And so that allows you to call toString on any object, even if it's not defined, because it's going to delegate to object.prototype and find toString there.
What does toString do? Just
right. It's just it returns a textual representation of the object. So usually you'll override this to say something useful about the object. It's used mostly by developers. Right? It's a way to get like an appreciation for what an object is. Yeah. Good. All right, good. So yeah, so that's the way you create prototype chains. Let's see. Yeah. Yeah. So there's a note here, but I'm not going to read it because it's confusing. It's probably best if you start using the prototype chain, and then come back to this and see if that note makes sense to you. Okay. Good. Now, yeah. So we've seen object.create, and we've seen using new. So here's a bit more about how new works. So here we have a dog, which is a function. It's a constructor, if you will. And here I'm doing dog.prototype.bark is equal to function, right? So I'm defining a bark function onto the dog.prototype object. Okay, and this is a way to do something that we've already done, right? So before we had a name property and we use object.create, and here we use new, okay, and we use dog.prototype as the object that is going to be linked to the new object. Okay, so if I do let Fido new dog, I'm gonna get an object, and it's going to be linked to dog.prototype. Okay, so this dot prototype object exists on every function. Okay, so you can always do something like this. You can take your function dot prototype, and you can add a function to it. And basically, in practice, that's going to allow Fido to bark. So this is an alternative to using object.create. Okay.
So basically, to understand it easily, is it like you can write your own classes or your own functions, create your own functions and attach it to the dog class?
Yeah. So yeah. So the language here is questionable, right? So there's no class here, and the function bark, the bark function is attached to dog.prototype. So that's a special object that gets linked to when you use new. Yeah. So, I mean, I think the answer to your question is yes, that's correct. But the language is important. Otherwise, it gets confusing. Right, so the bark function isn't on dog. You can't do dog.bark. That's not going to work. You have to do new dog and then make that bark.
Got it. Okay.
Mm-hmm. Yeah. So if you hear of classical prototypal inheritance, that's what people have in mind. It's the use of prototype like this to make functions available to the objects that you knew up by using new.
Are there any examples you can post, like in the Slack channel or something, like real-time examples, like and when it gets used?
Probably. I mean, it's used everywhere, really. Yeah, it's yeah. I mean, is there a particular example you have in mind? Because you could go on GitHub and look for code like this. It's easy to find.
Got it. Okay, no problem. Yeah, I'll check it out. Thank you.
Yeah. Yeah, good. And yeah, if you have a choice, I would say go with object.create. Don't use .prototype, don't use new, but you will see it. So it's a good idea to know how it works. Good. Now, if you're troubleshooting your code, you might be wondering, okay, what is this object delegating to? What is the prototype chain for this object? And unfortunately, there's no standard way of figuring that out. But you can try this code here. So you can copy this code in your console. And then if you do object.get constructors of Fido, for example, you're going to get an array of all the objects that it links to. Okay, so this should work, but it does use the constructor property, which is kind of arbitrary. So it might not work, but it might just work as well. So if you're ever wondering what is the prototype chain for an object, give this code a try. Otherwise, if that doesn't work, you'll have to go into the code and figure out where the links are created, where is new created, where is object.create called, and you'll have to figure out the history of your object that way. Good. So I hope you're not too confused. Any questions on prototypes? No. Good. So let's just say a few words about the new class syntax. Okay. So this is the new ES6 class syntax. Okay. This is another example of a word that is loaded. So we talk about classes, but they're not really classes. They're more like yeah. I don't really want to get into this, but if you're used to languages like Java or Ruby, you might think that a class is a definition and that instances are copies of that class and that kind of thing. And you might want to not think like this in JavaScript. So you really want to understand the prototype chain delegation, how that works, and that's all you have to understand. There's no real concept of a class. Good. So yeah, so here's an old style class here. This is the classical inheritance style. So you have the dog function with a capital D, and then I'm adding a bark function on the prototype. So whenever I new dog, I'm going to be able to bark. Okay. And here I have a poodle function. So this This is also a constructor. Okay, and here I'm defining the cry function, and that's going to be equal to the cry function from a new dog. Okay, so I'm reusing the cry function from dog within the poodle object, and here I'm linking the two objects together. Okay, so I'm linking the poodle.prototype to dog.prototype. So this is another way of saying whenever you do new poodle, link the poodle object with the poodle.prototype, but also as the next step, look up the functions on dog.prototype. Right? So you're linking the two objects together. So if you create a poodle, you're also creating a dog at the same time. It's gonna go there when you delegate.
Why not just create the bark function within the dog object? Like, why create it outside of it?
Outside of it. You're saying after this.cry, I could type in this.bark?
Yeah, and just create that function within the object, keep it all like center.
Yeah, you could also do that. That would be the same thing.
Okay.
Yeah. But if you did that, then the function wouldn't be on the prototype. So you couldn't as easily delegate to it. Yeah, good. Yeah, that's a good question. So if the bark function is created inside the dog function, this.bark is equal to blah, 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 then it's no longer a function on dog.prototype, okay? And so the poodle wouldn't have access to that. All right, if you did new poodle.bark, I don't think that would work. Yeah. Good. But so that gets a little advanced. But that's definitely something you could try offline. And if you have any questions, you can come into this channel.
For those of us who don't know object-oriented program, can you explain what we should think about when we see the word class in JavaScript?
Yeah, it's a class is in JavaScript. Well, so you'll see the word class in here in the new ES6 syntax. So this code here that creates a dog and a poodle, and then some kind of collaboration between the two, is equivalent to this code, which is nicer to look at. Okay, so dog is a class, so you can think of it as a definition for an object, right? Or you can think of it as an object factory, so that when you do new dog, you'll be creating an object, okay? And the properties and the behavior that new object will have access to are created in here inside the class. So here it says constructor. That's the same as our dog function. Okay, and we're specifying the cry property here. And then here we have a bark function. There's no function keyword. It's simpler. It's kind of neat, and you can create the bark function here. And then if you want the poodle to delegate to dog, you can use this new keyword extends. And so that's the new way, or the new ES6 class way of saying, if you can't find something on poodle, just look at the dog's prototype. All right, so it's going to delegate to dog. So here in bark, it's easier. We don't have to say all the stuff that we said here. We don't have to use this line, which can be cryptic. We just know that it's going to delegate to dog, and that's it. And here we're even overriding a function from dog. Right? So this new syntax is kind of nice, but it is strictly equivalent to this code here. The new syntax is really just sugar on top. So to the question, what is a class? It's just a definition for an object. It's a factory. It's something you call to get a new object.
You just said you were overriding the bark function in the last case, but not for dog itself, because that stays capitalized. Just for poodle, it goes to lowercase.
Just for poodles, that's right. Yeah. So if you do new dog, you get woof all caps. Right?
Yeah.
If you do new poodle, you get woof in small case. Yeah. That's a good example of how you would use object-oriented programming, how you would use the delegation to get different behavior. And yet you're kind of reusing the code. So this line doesn't really care what cry is on the dog object. It could be anything. It's just going to delegate to the dog and lowercase the result. So it's kind of like adding an extra processing step at the end. So you're reusing the dog class, but adding a little bit.
With this new syntax, do you find that you don't have any reason to use the prototype syntax?
Right. So so there's an edge case where you have to, where sometimes you might want to use the prototype syntax, but it's much rarer, which is nice. Yeah. I mean, it's meant as a way for you to avoid all this prototype business, and most of the time it's going to work. But I think, especially when you start using super to refer to a function on the object that you extend, once you start using super, I think there's a couple of special cases that come in, and you might have to use the prototype syntax. Good. Yeah, so a lot of React people will use this ES6 syntax, and it looks nice. It's easy on the eye, and it's easy to understand the intent of the programmer behind the code. So that's good. Although you might find that all this class business is just complicated, and I think you're right. It's quite complicated, and I find it easier to deal with literal objects, and if I want to link them, I use object create, and that's just a nice, modern, clean style. It's different ways to do the same thing. So you can choose your favorite, but if you really want to master JavaScript, you'll have to understand how both methods work. Good. So yeah. Let's just have a quick look at the readings here. Yeah, good. So you can have a look at the You Don't Know JS book and read a lot more about all the things that we talked about today. Feel free to go back to this prototype presentation as well when you're done, and you should also look at the homework here. So in this homework, you can, it works the same way. There's a repository, you can clone it, and you run yarn install to get all the dependencies, and then you want to run jest to run all the tests. The difference here is that you won't be writing tests, you'll be writing code. So all the tests are there, you can just run them, and they'll fail, and then your job is to make them pass by writing the code, and you'll have to use object-oriented techniques to make it work. And that's it. Yeah. And if you want to practice, have a look at these katas, come into the Slack channel. These concepts are not intuitive. They don't map onto something in the world the way other things do. So like if you have arrays or functions or parameters, that kind of maps onto something in the world, maybe to something mathematical or to something that we're used to. But object-oriented programming it's a new thing. It's something that developers have kind of created because they thought it was useful to them. It was a nice way of thinking about code, and it just grew. It just grew like that. It's a practitioner's kind of bag of concepts. So it can be difficult to master, but most of the time it'll be simple enough. We've talked about a lot of edge cases. Hopefully you won't see them if you're lucky. But yeah, once in a while you'll have a bug, and it'll be because of one of those things that we talked about today. So it's just a useful concept, useful thing to master. Good. Any final questions? All good. Okay, excellent. Then good luck, and we'll meet again on Thursday at the same time as today.
Thanks, Matt.
Thank you.
Thank you.
Thanks.
Thank you.
Thanks.